Hello all, I'm Dr. Pravas. In today's class, we'll discuss about the construction of Lr0 parsing table or Lr0 parser. We have already discussed about the theory or steps or algorithms of Lr0 parsing table in the previous class. Okay. In this class, we'll particularly discuss about the Lr0 construction of Lr0 parsing table or Lr0 parser. Okay, how to construct Lr0 parsing table with the help of a suitable example. Okay, see. This is the question. Construct Lr0 parsing table. Construct Lr0 parsing table for the following grammar. What? A is to AB, A to A, B to B. This is the grammar. This is one context-free grammar. Now we'll construct the Lr0 parsing table. Okay. So also one more thing in the question, verify the grammar is Lr0 or not. Verify the grammar is Lr0 or not. One more question also, verify the grammar. Grammar means this grammar. Grammar means this grammar. Verify the grammar is ambiguous or unambiguous. Okay. Then there are three questions in this in the given question. First, we'll construct the Lr0 parsing table. Second thing, we'll verify the given grammar is Lr0 or not. Third thing, we'll verify the given grammar is ambiguous or unambiguous. Okay. So now, in the first step, we'll construct the Lr0 parsing table. First, we'll construct this question. First question. Okay, how to construct the Lr0 parsing table? We have already discussed about the steps or algorithms how to construct Lr0 parsing table in the previous class. Okay, generally there are three methods. Sorry, generally there are three steps for Lr0 for construction of Lr0 parsing table. What are the three steps? First, add or construct the augmented grammar. Third one, the second step is compute the Lr0 items using closure function and go to function. In the third step, construct the Lr0 parsing table. First, we'll construct the augmented grammar. See how. See here in this given grammar, here S is the starting symbol. S is the what? Starting symbol. In the given grammar, S is the starting symbol. Since S is the starting symbol, so now we'll construct the augmented grammar. The augmented grammar is what? S prime to S. S prime to S. Okay. Okay. The augmented grammar S prime to S. So the next one here, just simply write, this is called augmented grammar. This S prime to S, here S prime to S, this is called augmented grammar. Augmented grammar. This grammar is called as augmented grammar. Okay. So in the first step, just write the augmented grammar and simply write or simply copy the rest of the grammar. Simply copy the rest of the grammar is what? S to AB, then A to A, then B to B. Okay, simply copy. In the first step, simply write the augmented grammar and then just copy the given context-free grammar prediction. Okay. Then we'll construct. Now we'll follow the second step. What is the second step? Compute the Lr0 item. Compute the Lr0 item. So see how to compute the Lr0 item using closure function and go to function. So first thing we'll write what? S prime to dot s. We have already discussed about what is the meaning of dot. In the just if you don't have any idea about why I'll write dot here, so just see the theory in the previous class theory. Okay. So s prime to dot s. I just write this is the augmented grammar production. Simply write s prime to dot s. Dot s means the Lr0 grammar will scan this s. Since it will scan the terminal, it will scan the non-terminal s. So now we'll find the closure of s. The closure of s is what? S to AB. The closure of s is what? S to AB. So simply write S2 dot AB, right? A to AB. See here in this production, the Lr0 grammar will scan. The Lr0 grammar will scan which non-terminal? A. So now we'll find the closure of A. Now we'll find the closure of A is here. This one, A to dot A. Okay. So this state is called as, this is I0 state. This state is called as I0 state. This is called as I0 state, or we can say initial state, See here how many different variables will scan. The Lr0 grammar will scan here S, A and small a. So there are three different variables are there. One is S, one is A and one is small a, right? So in the next step is the what? Go to function. So Lr0 parser will scan here S. So when means S means S prime 2, it will just scan what? S. So S dot means one dot just move towards right. Okay. So this is the completed. Okay. So this state is called as I1 state. This state is called as I1 state. Okay. Here, see, it will scan what? A. So in this step, it will scan A, means S2 what? A dot B. Since it will scan next, the Lr0 parser will scan what? The non-terminal like B. So now we'll find the closure of B. The closure of B is what? This one. So B2 small b dot small b. So this is I2 state. This state is called as I2 state. Okay. Now see here A2 dot A. Now thus it will scan like what? A2. One dot move towards right means A dot. This is called I3 state. This state is called as I3 state. Okay. So here I1 state is completed. I3 state is completed. Now we'll scan. Now we'll explore I2 state. See here how many different variables that will scan. Capital B and small b. Capital B and small b. Okay. So here first Lr0 parser will scan the capital B means what? S2 AB dot AB dot. Okay, this one is completed. So now we'll see small b. The Lr0 parser will scan small b. Small b means what? B to B dot. So just make the number I3, then this one is I4, this one is called I5. Okay, so there is nothing to explore, there is nothing to explore, so stop here. Since there is nothing to explore, so stop here. This diagram is called as DFA diagram. This diagram is also called as DFA diagram. Sorry. Right. So remember one thing. This state means I1 state is always final state. I1 state is always final state. I1 state is always final. Why I1 state is final state? We have already discussed in the previous class. Because this I1 state contains augmented grammar. Augmented grammar prediction. The use of augmented grammar prediction is only for accept. Only for accept. Okay. So that's why I1 state is always called final state. Which one is the initial state? I0 is always called the initial state. So this is the overall DFA diagram we can say. Okay. So now we'll construct the Lr0 parsing table based on this DFA diagram. Remember, what is the meaning of Lr0 items? I just clear you. Lr0 items. This one, each one is called as Lr0 item. Means I1 state is one Lr0 item. I1 state is one Lr0 item. I2 state is also one Lr0 item. I3 is also one Lr0 item. I4 is one Lr0 item. I5 is also called as one Lr0 item. So that means the canonical set of Lr0 items. Here I contains, we can write like this. See, here I contains what? I0, I1, I2, I3, I4, I5. Okay, so these are called as the Lr0 items. Okay, so closure function, how to use closure function in this means to find Lr0 items we have already discussed. So since S prime, since in the first production means this production, it will scan means Lr0 will scan S, it will scan the non-terminal like S. So we'll find the S closure of S. We'll find the closure of S. The closure of S equal to dot AB. Since it will scan the non-terminal like A, so it will find the closure of A like this. This is called as the closure function. So what is the meaning of goto function? We have already used the goto function. Means we can write like this. Here goto function means suppose I1 state. Suppose here I1 state equals to goto of what? I0 comma S. I0 comma S. Goto of I0S. I0S means what? S prime to S dot. Okay. So I1 state contains what? I1 state equal to goto of I0 comma S. I0 comma S, or we can write like this, or we can write like this. This is called as the goto function. This is called as the goto function. Similarly, we can write suppose I2 function. What is the meaning of I2 function? I2 function equals to goto what? I0 comma A. I0 comma A. Okay. I0 comma A means what? S2, simply write like this. S2 what? A dot B, B2 dot B. This is the goto function for I2. We can write like this, or we can simply write like this. Okay, clear? So now we'll construct the table. Now we'll construct the table. Okay, see the how to construct the table. What is the size of? Now here we'll find out the size of parsing table. Here the size of Lr0 parsing table. Size of Lr0 parsing table equal to number of stairs. Number of stairs into non-terminal plus terminal plus 1. Number of steps, how many stairs here? Number of stairs are 1, 2, 3, 4, 5, 6. How many non-terminals in this grammar? See, how many non-terminals in this grammar? S, A, B. The non-terminals are here. What? S, A, B. Don't include this S prime. Don't include this S prime. How many terminals are here? Terminals are 2. Means A and B. So here this is 3 plus 2 plus 1. So 6 into 6 equals to 36. Okay. So now we'll find. Now we'll construct the table here. See. Okay. So just count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 into 6 called 36. This is called Lr0 parsing table. See the left side. The left side it is the number of stairs I0, I1, I2, I3, I4, I5. These are the number of stairs. So first we'll write action. We'll write action. Action is here A, B, dollar. Then go to. Go to means what? How many terminals? S, A, B. Okay. Actions means this part. Actions means this part. Go to means this part. Go to means this part, right? So now we'll fill the table. Now we'll fill the table. Just see how to fill the table. First we'll fill go to action. First we'll fill go to action. Go to action is always the terminals. Sorry, non-terminals. Go to actions means always non-terminals. See, go to actions means always non-terminals. So just see how many non-terminals here. How many non-terminals? See, this one is the one non-terminal. This is one non-terminal, and this one is one non-terminal. See, I0 read S. I0 read S goes to I1. So I0 read S goes to I1 means 1. Similarly, I0 read A. I0 read A goes to I2. I0 read A goes to I2 means 2. Okay. And one more. I2 read B goes to I4. I2 read B goes to I4. Okay. All go to actions are clear. Go to actions are only non-terminals, means capitals. S, A, B. Okay, now we'll shift. Now we'll shift. Okay, go to actions are clear. Now we'll shift. We'll place shift action. We'll place shift action. We'll place shift action. Now we'll place shift action. So how to place shift actions here? Shift actions are always, remember, shift actions are always terminals. Go to actions are always non-terminals, but shift actions are always terminals. How many terminals? Just A and B. Here I0 read A goes to 3. I0 read A goes to 3. 3 means we will write as 3. S3. S3 means shift action and its number is 3. Means it will go to third step. Just see one more. I2 read V. I2 read V goes to 5. I2 read V goes to 5. 5 means S5. S5. Okay. Shift actions are clear. All shift actions. Now shift actions are clear. Now we'll see the reduce action. 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 Reduce action, just make the number. Just make the number except augmented grammar. Except augmented grammar 1, 2, 3. In a sequence order, just make the number 1, 2, 3. Right? So reduce means which predictions are completed action. Which predictions are completed action except augmented grammar. See, I1 state, this grammar is also, this prediction is also completed action, but this is don't consider this one. Don't consider the I1 state. Okay, except I1 state. Now we'll see how many predictions are completed. I2 there is no completed action. I3 is this grammar or this prediction is completed action. Completed means dot at the rightmost end, means this dot at rightmost end, this is completed action. I4, this is completed action because dot at the rightmost end. This one is completed action because dot at rightmost end. So there are 3 reduced actions. There are 3 reduced actions. Just see. In I3 state, what I3 state, the reduced actions are happening. Just see the number of, means the prediction number. The prediction number A to A. The prediction number A to A is R2. The prediction number A to is R2. So now we'll place R2 in all action states. R2 in all action states of I3 state. R2, R2, R2. Okay, just place R2 in all action states of I3 state. Okay. Now we'll see I4. What is the in I4 state? It's one also the reduced action in I4 state. Just see the prediction number S2AB. S2AB. S2AB means R1. In I4 state, R1. This is R1. This is R1. This is R1. Okay. Now we'll see. Now we'll see one more reduce action. See I4 state, in I4 state, sorry, in I5 state, one reduce actions also happening. B to B, B to B. B to B means the prediction number. The prediction number is what? The prediction number is R3. So in I5 state, this is R3, R3, this is R3. Okay. So go to actions are clear, shift actions are clear, reduce actions are clear. So this is the final Lr0 parsing table. Okay. So first question was what? Just see the first question. Construct the Lr0 parsing table. Construct the Lr0 parsing table. So we have already constructed the Lr0 parsing table. Okay. What is the second question? The second question is verify the grammar. Verify the grammar is Lr0 or not. So this grammar is Lr0 or not. How to verify this grammar is Lr0 or not? Remember one thing. If there is any multiple entries in the Lr0 parsing table, if there is any multiple entries in the Lr0 parsing table, then this grammar is not Lr0. So just see, there is no multiple entries in the Lr0 parsing table. Multiple entries means what? Means one box. Means suppose this is one box. This box contains multiple entries. Means also S3 action, also R5 action, like this. This is called multiple action. Okay. Okay. So since there is no multiple entries in the Lr0 parsing table, so this grammar is Lr0. This grammar is Lr0. Just see the rules here. If the Lr0 parsing table contains, if the Lr0 parsing table contains multiple actions in the same box, either this is SR conflict or this is RR conflict. SR conflict means shift or reduce conflict, RR conflict means reduce or reduce conflict. Then the grammar is not Lr0. Then the grammar is not Lr0. Since the given grammar, since the given table does not contain any multiple entries, so this grammar means this given grammar is Lr0. This given grammar is Lr0. The given grammar is Lr0. Okay. Now, what is the third question? Just see the third question. Verify the given grammar is ambiguous or unambiguous. Okay. Now we'll see the grammar is ambiguous or unambiguous. Remember, this is very important Venn diagram. Every Lr0 grammar is unambiguous grammar. UG means unambiguous grammar. Unambiguous grammar. Okay. Every Lr0 grammar is unambiguous grammar, but every unambiguous grammar need not be Lr0. See, every Lr0 grammar is unambiguous, but every unambiguous grammar need not be Lr0. Since the grammar is Lr0, so since the grammar is Lr0, so this grammar is also unambiguous grammar. Okay, so in this way we can construct the Lr0 parsing table. We can also check the given grammar is Lr0 or not. We can also check this given grammar is unambiguous or not. Okay, so in the next class we will also discuss about Lr0 parser, means with some different examples. Okay, thanks for watching.